One of the ways to add displacement map to an object is through the render tree. So you select your objects, open the render tree, and connect shaders onto the displacement port. So for sake of demonstration, I'm going to use a share shader. So a share shader is designed to evaluate the input, whatever that is, either Boolean, color, or integer, and return the value to the output. So it's some sort of a pass-through. So whatever is basically being evaluated here at the input is going to be returned at the output unaltered as is. So I'm going to go get a share scalar and actually connect this one directly to displacement. So as you can see, the displacement map occurs because the actual value is being returned for every vertex to be 0.5. So if I set it to 0 here, it means that every vertex during the displacement map will be pushed by 0 Softimage units. So if I start to increase this one, I can actually start to inflate an object slightly. It's the same thing as push operators at the modeling level, except that this operation is done at rendering time, so XSI is not aware of about the geometry being modified right now. So as you can see, as I modify the values, I can get the actual displacement map to occur. So this is a very simple displacement tree. Let's call it this way. Now we have every object has a geometry approximation. So under the object, there's one that is being propagated from the scene root such that every object has at least one geometry approximation being assigned to it. So if we click on it, obviously this XSI will prompt me if I want to make this property, this share properties, to be made local, and then I will say yes, such that if I apply modifications or modification to geometry approximation, it will only affect that particular object and not the entire scene. Now under the geometry approximation, we have different actual tabs. So let's focus on displacement tab for now. As you can see here, there's different displacement or tessellation techniques. We'll get back to these particular techniques later. The important parameters I would like to focus on is the max displace. So as you can see here, the share shader is returning a value of 1. So let's even push it to 2. I can actually inflate it up to 2. But if I go beyond 2 in terms of displacement map, it's going to be clamped by the displacement map. So as you can see, if I type 6, it will never push the surface further than 2 in terms of units. The reason why this is done is mental array is a lazy architecture system. Well, it just do the work whenever it's needed. So by having this max displace, it allows the actual object to have a finite bounding box, including the displacement map, and that allows mental array to only tessellate object whenever a tile covers that bounding box, which include the displacement map. So if I start to lower this value, you'll see that I'll be clipping the displacement value to be maxed out at the value of 1. If I get 0.5 or even 0, for example, I can totally disable displacement map locally on the object, even though there's a displacement value. If, for example, you do give it a value, you'll see that these warning will basically be logged by mental array, and it tells that basically the value goes up to 6, but it was clipped to max 0.5. This is just a warning. It's just to inform you that what you ask and basically what is being returned is different. So should be considered as a warning. So that is a first simple displacement map example. In the next session, we'll go in a little bit more detail. Thank you.